So I'm going to be doing chapter 7 today, just section 1, which are Z-based confidence intervals for population mean, where the standard deviation is known. So here, just remember that we need to convert the standard deviation into the standard deviation of the sampling distribution. This is from chapter 6, so if your memory is kind of foggy, just go back to chapter 6, look at it. Only take 30 seconds to refresh your mind. And also the central limit theorem here, it's just telling us that make sure our sample size is greater than 30, and that's that. Here they're saying that the confidence coefficient is 1 minus alpha, and 1 minus alpha multiplied by 100% is it's called the confidence level. So just be familiar with the terminology. They might trick us up on the on like a test or something, but not much you can test us about that. So on the right hand side of the equation, this is the more important part. If you memorize that, you're basically good for 7.1, which is basically the sample mean, which are given, plus or minus the z-score. We're going to be given this. We're going to be given the alpha, I mean, so this is the only thing that we're going to need to calculate. The standard deviation divided by the square root of the sampling size. So they're going to give us n, they're going to give us sample distribution, so I mean standard deviation, they're going to give us the sample mean, and they're going to give us alpha. So we're going to be basically given everything. To solve the problem, just need to plug it in. Now, some of you might be wondering why we're going to be doing alpha divided by 2. That's because we want to give we want to get the right hand tail and the left hand tail, the two different tails, which is going to be shown by the plus minus here. So let's see what it'll look like on a graph. So yeah, just to reiterate my point, the alpha divided by 2, that's the right hand area right here, and the left hand. So this is where the plus and minus come into play. And using those two, we're going to find the confidence interval. So the confidence interval is basically this. I said this over and over again. This slide's so repetitive. So we're going to be working with a 95% confidence level. So this will, on a question, it'll show up like this: 95% confidence interval, and they'll give us the sample mean, standard deviation, and the sample size. So to find 95% confidence level, we'll just do 1 minus alpha, and alpha clearly being 0.05 here, and divided by 2 is 0.025. So we know that the area that we're looking for under the curve for the right hand side is 0.025. So we need to take away 0.5 minus 0.025 to figure out the what z 0.025 is, which is going to come out to be 0.475. So basically 0.5 minus this equals this. Going back on the graph, because we're going to take a split halfway down here. This all represents 0.5, and if this little non-shaded part is 0.025, 0.5 minus 0.025 should give us this part, which is shown on the table. So let's look at that. So we're going to be looking for 0.475 on the table. It is right here, just 1.9 and 0.06. So this is how we got 1.96 for z-score of 0.025. It's actually not bad to memorize this number because it's going to show up often. Same thing with the 99% one. So if you do a couple of problems, I think you'll memorize it off the top of your head. But here we go. So yeah, z-score for this is 1.96, and for 99% confidence interval, it will be 2.575. As an exercise, I guess you can do this 99% one. Might be fun. I doubt it. So yeah. So this is what a sample question would look like. They'll give us the sample mean, the standard deviation, and the sample size. So we just, for a 95% confidence interval, we just plug all these numbers in that we found. We found 7.012, which is given, plus or minus 1.96. That's actually the one we found. Divided by the standard deviation over the square root of the sample size, which is going to give us 7.012 plus or minus 0.0083. Now, this is the smaller half, this is the bigger half. So 7.012 minus 0.0083 goes this side, plus goes onto this side. It's just conventional to keep the smaller one here, and the larger one here. Anyways, this must have been really easy. Hopefully you didn't go to sleep. Yeah, thanks.